Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you an introduction to the idea of regression. Well, suppose that your objective is to study whether there is a linear relationship between two variables, and therefore these are the steps that you have to take. So the first one is you're going to draw a scatter plot and see if there is any sort of indication whether the relationship is linear. Next, in order to be very sure what's the value of the correlation coefficient, then you can compute that using the given formula, which you have already seen in the previous video. And the third step is, if you want to see whether this value here is significant, what you need to do is you need to do a hypothesis testing. So this one on the third step is you need to do hypothesis testing, and if the result is significant, if the correlation coefficient here is significant, or in other words, if you reject the null hypothesis, then you will move on to the fourth step, which is to determine the regression line or the line of best fit. And here is what we're going to do in this video, which is just, I'm going to give you an introduction to the idea of regression line or line of best fit. Yeah. So the line of best fit is defined as such. So this is a line that minimizes the sum of squares of vertical distances from each point to the line. Okay, and I'm going to explain this through a simple figure which is given here. So suppose that these are all your data points, and if let's say you can construct a line that go through all these points here, so let's say that this is the line, and so if you talk about the regression line or the line of best fit, the definition says that it is the line that minimizes the sum of squares of vertical distances from each point to the line. So I'm going to explain to you what is the vertical distances from each point to the line. So here are the points, and if this is the line that is constructed here, you can see that the vertical distance from this point to the line here, so vertical distances, that's the meaning of it. So this is the first vertical distance. For example, from this point to this, you have a vertical distance which you can obtain based on the graph given here. I'm going to call this vertical distance as D1, the first distance. From this point to the line here, the vertical distance is D2. This one, because it is right on the line, therefore the vertical distance here is D3, and you know that it's going to be 0 because there is no vertical distance from that point to the line. The vertical distance is 0. You can see that clearly. Now from this point to this line here, the vertical distance is going to be called D4. This is D5, and probably this is D6. So next is the meaning of sum of squares of vertical distances from point to the line. So we need to find what is the squares of vertical distances from each point to the line, which means you need to sum up all those values. So we need to sum up the square of vertical distances. So this is the meaning of that. You need to square all the vertical distances here. So this is what's going on, and the result here is the sum of squares of vertical distances from each point to the line, and I'm going to call it as I don't know, maybe D. So the value of D here has to be a minimum value. So when it is a minimum value, therefore we can say that this is the line of best fit. Okay, so so if you have, for example, these points here, you can see that there are possible lines that you can construct that goes through all these points here. For example, this could be the line that you can construct, the straight line, or somebody else might construct the line that looks like this because they think that this line goes through all the points fairly. So here, in order to choose which one is the best line, is it the blue one or the green one, you have to obtain the value of this for the green line, and you have to obtain the value of this, sorry, for the blue line. So you need to obtain this in practice. What you need to do is you need to obtain what's the value of this for the blue line and what's the value of this for the green line, and which one of this is minimum. So if it is the minimum value, here will correspond to the line of best fit, because the line of best fit is defined as the line that minimizes the sum of squares of vertical distances from each point to the line. So you can see that based on this process here, you can have many possible lines. It is not just restricted to 2 lines. Somebody might come up and say, hey, I think we could have a line that looks like this. So which one is the line of best fit? So now it becomes a bit impossible for us to draw all the possible lines that passes through all the points on the graph here, and then finding all the sum of squares for each line. So it is a bit impossible to do that, and because of that, we have come up with a simple way of obtaining the line of best fit, which is we are going to construct a mathematical equation. So the line of best fit, even though in definition is given as a line that minimizes the sum of squares of vertical distances from the point to the line. So that is the idea. But in practice, if you want to consider constructing all the lines here, it is a bit impossible to do that, and therefore we have come up with an elegant way to obtain the line of best fit, which is given by this formula here. And you see that this is the line of best fit, and this is just a linear equation, which I think you are already familiar with it. This is going to be the intercept, and this is the slope. X is the independent variable, and we're going to call this y prime to just differentiate this value with the value of y. So before this, we have already allocated x as independent variable and y is the dependent variable. So we're just going to use the notation of y prime to differentiate between this line of best fit with the value of dependent variable. Now A can be obtained by implementing this formula here, and B can be obtained by implementing this formula given here. And to illustrate how you can apply these formulas to solve a question related to the linear regression, well, that one I will explain in the next video. All right, thank you very much for watching.